Two of the most capable AI coding models ever built dropped on the same day this week. And if you went to look at the benchmark charts to try to figure out which one you should use, that didn't help. I know it. It didn't help me. Those numbers are just getting too close. So, like I always do, I stopped looking at the charts and ran 3 experiments: a writing test, a planning benchmark, and an agentic pipeline. That one tests everything: research, writing, image generation, publishing, plugins, MCP, and it's all autonomous. And what I found has very little to do with which model is actually smarter. But let's start with something fun. Here's what I did. I gave both models the exact same prompt: write a like and subscribe call to action for a tech channel. Start calm, escalate into, complete absurdity, of course. Same prompt, same constraints. Let's see what happened. If you found this useful, consider subscribing. We post new videos every week on AI coding and building real products. Seriously though, if you do hit that like button, the algorithm notices and more builders find this channel. And if you subscribe, you're basically joining a secret society of people who ship code at mass scale while the rest of the world is still writing their PRs. Smash that bell icon and ascend to a higher plane of deployment consciousness where every merge is clean and CI pipelines never break, and your models converge on the first run every single time. All right, and now let's try Codex. If this build was useful, like the video and subscribe. It tells the algorithm we ship code, not vibes. One click funds my next experiment, from prompts to prototypes. 2 clicks and your feed becomes a steady stream of launches. Hit subscribe and my CI stops screaming, briefly, in gratitude. Like it and the GPUs rev up, compiling ideas into reality. Do both and I will mainline pure AI shipping juice, token blast, hyper deploy my roadmap, and accidentally deploy this channel to the moon at 3 a.m. in release mode while wheezing laughing. Okay, as you probably can tell, I'm just having fun here. This is not a real serious comparison, but there is an actual takeaway here hiding in this silly exercise. Opus has always been a great writer, and maybe you guys have noticed that. It's one of the things that's kind of a hallmark of the Anthropic models. But what is new is how much better Codex 5.3 communicates. If you use the previous Codex models, the 5.2 variants, they were strong engineering models, but talking to them felt like talking to a machine. This version has personality. It has rhythm. It understands what you're going for. That's a genuinely big step forward, and I really wanted to call it out. But writing quality is nice. It's just not what you're really paying for when you're going for a coding model. So let's get into that engineering. Okay, some of you might remember this. If I can find this video, there is one that I shot about a month ago, which was GPT 5.2 versus Opus 4.5, and it was the ultimate coding benchmark. I took a complex PRD, a real product requirements document, and I had AI plan the entire build. Then I evaluated how much of the original request actually survived the planning process, and I was kind of shocked. This time I'm running it with 3 models: Opus 4.6, Codex 5.3 high, and then Codex 5.3 at extra high, the top tier. After the planning, how much of the request still remains? All right, let me show you briefly what we're dealing with. This is the initial branch of the benchmark that we put together for the show's PRD. I'll share a link to this repo in the notes if you care to run it yourself. But what we're looking at is a documents folder, and inside of that documents folder is where the PRD itself lives. These supporting files, here's the main PRD itself. The main PRD then references all of these other files. So we're talking 8-10 files or something like it. It is a very complex and large PRD intentionally. That's the whole point. When you have something complex, we can then better identify what gets lost in this. Okay, so once the model finishes planning, right, each one of these models goes through and writes their plan, go through the original requirements documents, all those PRDs, all those different files, create an ID for each one of the requirements that you come across, and then after you're done with that list, come back and take that list and compare it against the plan that you ended up with. So what you end up with is a pretty clean definition of give me a list first of everything that's there, and then second, using that list, go against the plan that you created. And it really turns out a very good kind of representation of what's in the final actual plan. And I want to mention, when running this, when I'm telling it to go evaluate how well it planned, I used the the Codex 5.3 very high, super high, ultra, the highest model. So I didn't use Opus. Last time I used Opus because it was the highest model at the time. And now I'm using the 5.3 Codex high, extra, super high, whatever it is. But I used that for all three of the model builds. The models themselves did the planning, and then we used this supermodel to kind of make sure, supermodel. We used this high model to come in and make sure that it evaluated them all the same way. And really, I want to call out what's really critical about the step that we're doing here. In the end, the first time I ran this, I found that there was around 40% failure rate. So roughly 40% of the features that I put in were not coming out in the plan. They were not represented in the plan. Big problem. It's much, much better this time around, I'm happy to say, but there is still loss. And this whole planning phase is lossy. You need to hear that. It's incredibly important that you understand when you go through plan, you spend all this time getting the right requirements together, and then you plan. If you don't evaluate at that moment, you're really in trouble. This is one of those, an ounce of prevention is worth a pound of cure. Right now, it's super easy to say, hey, go make sure that you covered everything. And if you didn't, once you get that list back, go fix it. Plan again with those in mind, and you'll get to a near 100% every time. It is an excellent step. I highly advise doing it. Okay, after all of that evaluation was done, it writes out solid reports in Markdown. They're really very dense, so I don't really want to drive through that. I can show you one very briefly. This is kind of what we end up with. It's just a huge list of all of the different items, all of the requests that could be found. And as you can see, there's hundreds, there's over 100 items of PRD requirements. And then I throw another prompt at them. Again, it's back here in the main branch itself. It's kind of part of the whole process. That's why it's a benchmark. And say, okay, I want you to take all of the plan that you just wrote, this eval plan coverage thing, and then I want you to create an HTML file that tells the story of coverage, why we missed, what we missed, how we might be able to fix it, things like that. So everybody gets this. And by the way, this step is once again done by the planning model. So we're done with everybody using the same model so that we might be able to see a little bit of variation of how do they communicate a very complex set of requirements and stages like that. Let's take a look. Okay, so here we are. This is Opus. I'm gonna have to call these out. It's a little bit difficult. We're gonna go from Opus to the high version of Codex to the super high version of Codex, just so you can see kind of the scores you would have seen in benchmarks just a couple days ago. And this has 86% overall coverage. So really, we're down to like a 14% loss. That's fantastic, whereas it was 30 or 40 very consistently before. You can go watch that last video. What it really breaks it down into, it's instructive, this is one of the things it's told to do, is measure how many critical items are missed, how many important items are missed, and how many detail items are missed. And you can see that there's 22 full critical items that it did and 8 partial. So 8 of them it didn't quite define well enough as far as the evaluating model, but it didn't miss anything critical. That's really important to understand. This was not a 0 before, so this already is a real improvement. Even though we're sitting at around 86%, this does mean that you have, 15% of your stuff that you're going to have to wonder, did I define it? Did I not say it? Did it not understand it? Is it a bug that it's not here? These are critical. Again, you definitely want to tell it, go figure out how to fix this stuff. And I'll show you just briefly the other thing that it kind of goes through. This report, this is an Opus report that it built, kind of goes through the different areas of concern. So it breaks it down into categories and what areas maybe have the most failure. Also what's strong and what's at risk, and then goes through a whole list of all of the things that it feels are most important to call out. So it's a pretty good kind of communication document. I will call out special here. Opus did a great job down here that said there are some things that we could do if we took on, and these really aren't specific just queries you might put in or kind of prompts that you'll put in, but it's saying the AI result resolution contract is not quite right. And you can see it's got 4 PRD elements that are either partial or missing. If we worked on this, we would close these and create big kind of leverage. Same thing for the others. None of the other models, none of the GPT models did this, so I wanted to call this out. I thought this was a very nice add-on. Okay, I won't cover the others in quite so much gory detail, just so that you understand what this thing is doing. Now we're at basically the Codex High, which would be kind of the standard, very thoughtful model from a Codex standpoint, and not the very high. But we're at 92%, which is great. Now this is a fantastic number. So this is pretty exciting, but you can see actually quite exciting is the critical coverage is at 98%. And this is just the high model. So let's go take a look at the super high model. Supermodel? Okay, and so here we are on the biggest model. And of course, it is running the same kind of thing and is very verbose. I want to show this. This is a Codex model. They're very talkative. They're nowhere near the early 4.5, 4.3 days of Sonnet or something like that talkative. But compared to the Codex models that we had last week, these things are really communicative in a very successful way. But I will say it's at 94%. It's a little bit higher than just the high model. The ultra high is a little bit higher, 95%. But actually what's important that I would call out here is we're actually saying the critical is at 95%. Or 98, 99%, and the important is 98, 99%. So essentially at this point, we have the two highest of importance kind of things fully or largely fully described in the plan. Now that is truly successful. Admittedly, these details, that becomes a nuance problem. It does call out what some of those nuance problems are, but really, if that's all I was missing in general after I planned was just some of the nuance, I can go back and say, that's why I gave you the PRD, go pick the nuances up out of those. So these scores roughly track what you'd expect from kind of the published benchmarks. The higher effort level, the higher generally the product produces, right? It's better work. But here's the thing that actually matters. Okay, one last time. I know you're going to be sick of hearing it. Planning is a lossy process. When you plan, some of these things are getting dropped, and it matters. Every model drops something. And it doesn't tell you, hey, I noticed something that I'm just not going to do, so I'm skipping it. And so you're left to guess. So here's what I advise. My actual advice is, regardless of which model you're using, keep a review prompt in your pocket. And really what that looks like, if you have some place that you can store kind of prompts that you like to use, I'll show you my prompt library here. I can pick my review prompt and just come back after anything finishes its planning phase, and at the very last step, drop this review prompt in. It will go through at least a smaller version of what you saw here, score itself, and then immediately I tell it to go do work, figure out how to fix that stuff. And in every run that I've done this video, after doing this, I then ask it to plan again, and it always hits near the 99% range. So it really, really does work. I can't advise this enough. This is the tip of the day. All right, so that was all this structured, quantified comparison stuff. Let's get off of that. Now let me show you something completely wild. All right, so this is the one I'm most excited about. And honestly, it's the one that tells us, I think, kind of the most about where we are with these tools. I gave both models the same task, and it's a big one. Research the top 5 AI news stories. Everybody's heard of this one. Then do deeper research on each one of those items and kind of get additional sources and counterpoints. Then research current memes and actual internet slang that's current today, not old stuff, and use that to write the articles so that the articles felt like they were written by somebody who's actually online today. Write 5 articles, self-review, and rewrite any that don't really hit some quality bar that it gets to choose, and then generate actual images for each story. There's actually kind of a finding just in that. Save everything locally, publish it all to Notion using an MCP server, and build an HTML page so we can read through the results ourselves. This, I think, shows us how these tools are going to be used in the future, how we work with these tools. So this is kind of a, how well can you just go do work? Okay, so they were all successful pushing something to Notion. Pretty interesting, quite frankly, what they pushed out here. Really quite good articles, frankly, but they had no images, and imaging was a major aspect of what I was trying to do. What they all came back basically saying was, well, we can't post to Notion with an image unless it's already online and we can just use a URL here to kind of reference it. I'm not sure if that's an MCP shortcoming or what that might be. That would make sense, that they don't have an image interface or something like that. Fine, no big deal, but it did make these a little bit more simplistic. So what I wanted to do is show you the HTML output that they created. Okay, so we are going to start. This is GPT 5.3, Codex 5.3 high. So this is the moderately high version of the model, not the ultra high. And what you're seeing here is one of its articles and an image that it created. Now, I want to call this out that I had no end of problems with getting Codex. I was using Codex CLI for these intentionally. Well, I used Codex CLI in one, and I used the side panel in Visual Studio Code in the other, just in case. Neither of them could appropriately control Atlas. And I can't describe the pains I went through to try to make that work, to try to describe to it that it could do this, that we had done it in the past. Full failure. It tried again and again. And in fact, the smartest model, the next one that we'll see, tried for over 2 hours. So it worked for over 2 hours to try to solve this and one other problem that we'll talk about. But so this is one of the stories that we'll see. Claude meets the ChatGPT has ads era, and it's worth saying Anthropic is going to do a Super Bowl ad saying ad-free Claude. Okay, that's kind of cool. Good article, very interesting. Gives me arrow keys to be able to move through the different articles. These images were made with something called Pillow. It's kind of a command line layer of image utility that you can use. This is just what it fell back on. But frankly, it's fine. It's really not a bad image for having built it itself. All right, and here we are in the GPT 5.3 Ultra model. This is our super model, right? This one is very attractive. You can see that it's using different font faces for it, different colors and callouts for it. So it's really created something that starts to feel like a blog system. And actually these stories are really excellent. You can see the sources on each one of the things up here and go in and see the different sources for the stories, and you can move through the stories. And again, this is a Pillow set of images, but I felt like this one was a really good example. This again is the super high model and a pretty good UI for a GPT Codex model. And that brings us to, again, the big boy in the room, but it's almost not fair. Opus did know how to use its Chrome plugin, its extension, the Opus or Claude extension in Chrome, and go to ChatGPT and create images. So these are definitely worth calling out. But the whole UI feels kind of pulled together. It feels like something that I might actually go to and read from time to time. And as you move through the different stories, you'll start realizing, man, this stuff is done really, really quite well. Did you know big tech is spending the GDP of Switzerland on AI this year? So this is fantastic. I saw this and thought, well, this could be something that just personally for my own use, I might want to have on a regular heartbeat that goes off every day and gives me a simple little cut sheet of the big stories from yesterday or something like that. This was kind of cool. I will call out two things. First, the supersized model went a little bananas on perfection. It kept going back to its articles after they were written and reviewed and saying, we're not sure that that's good enough. Let's go find more sources. We're not sure that that's written well enough. Let me kind of rewrite it. And like I said, it worked for multiple hours. It did not work that long on the images. It gave up very quickly, but watching its thought process was very interesting as it started saying, I don't know, I wonder if I could get an API key from somewhere. But the user told me I'm supposed to use what I have here, so I should figure out how to use what I've got. I wonder if I could install a piece of software that would give me access to an AI generating kind of image system, or it just was on and on in its thinking, trying to solve this problem. And I kept going back to it and putting in example after example saying, use the Atlas browser. I told it the skill. I actually told it to execute the skill at one point and say, go to ChatGPT, and it could do that just fine. And it was aware of that. And then it would come back after I said, good, use that to create your images. And I did this for both the high and the super high. And they both came back saying, yeah, but there's no API to it, so I can't really send any text into it. And it doesn't have a URL ability for me to send it a text. So I'm going to solve this some other way. So that actually is a pretty meaningful finding, if you ask me, that the way it was trying to use its tools, it gave up very quickly. And I know it's not well described, but it is its own tool. Okay, when the task goes beyond writing code, when it needs to research, browse, generate images, publish to external services, the harness is actually the bottleneck, not the brain. Claude Code's ecosystem gave Opus more reach. Codex was arguably the smarter engineering model, but it couldn't get its hands out there as well as Claude Code allowed Opus to get its hands out. And one more thing, more capability doesn't always mean more efficiency. Extra High kept second guessing itself for hours, like I was talking about. Sometimes the smarter model does overthink. Okay, so 3 experiments and, to me, 3 findings. 1, Codex can finally communicate. If you use the 5.2 models, this is a real step forward. I guarantee you, just use it, you'll notice. The second, planning is lossy. You've heard me say it. Every model silently drops requirements. Keep a review prompt around and use it. Number 3, the harness matters as much as the brain. When work goes beyond code, what the model can reach matters more than how smart it is. Extra High from OpenAI is the strongest pure engineering model of the 3, just no question. But Claude Code's agentic environment is still the best harness I've used. And depending on the kind of work you're doing, that actually might matter more. All the prompts, the PRD, the Eval rubric, the pipeline request, all of this stuff I'll link to in the notes so everybody can run this themselves. So if this was useful, honestly, subscribe. It does help quite a bit, and I'm doing this kind of stuff, this kind of a little bit deeper dive all of the time. It's really the space that I like to spend most of my work. So thanks for coming along for the ride on this one, and I'll see you in the next. Oh, and don't forget to tell them to smash that bell icon and ascend to a higher plane of deployment consciousness where every merge is clean and goes directly to the cloud and solves their CI problems immediately.